Good morning, good afternoon, and welcome for all of you. My name is Aristidis Betzios. I work in Danieli and as Director of the ABM São Paulo Regional, we are coordinating this webinar. The ABM, Brazilian Association of Metallurgy, Materials and Mining, is just celebrating its 75 years. And as part of its digital diffusion, technology and innovation program, we are starting now the webinar, The Current Technologies in Compact Plants for Flat Steel Production. It will be in the form of roundtable, and will present the recent innovative developments such as the thin slab casting, endless casting and rolling, and universal endless plants. In other words, we will see the actual state of the art for flat steel production. To do so, we are very proud to count with the specialists of the main technological suppliers, the companies that are well known as front leader in innovation solutions for the steel industry. We will have here Mr. Bjoern Kintscher from SMS Germany, Mr. Andreas Jungbauer from Primetals Austria, and Mr. Alessandro Pigani from Danieli in Italy. We have also the pleasure to count with Mr. Marcelo Carboneri to conduct the agenda, to introduce the speakers, and to moderate the question and answer section. Mr. Carboni is a Master Metallurgical Engineer from Politecnica University of São Paulo, MBA from FGV, Fundação Getúlio Vargas. Mr. Carboni have 20 years experience in the steel industry, developing products and process. He worked at Aços Vilares, Sidenor, Gerdau, and CBMM. Currently, he is the technical manager in Gerdau and independent consultant at Embrapa Tecnogreen Polytechnica USP unit. Professor in several open courses in ABM, he coordinates projects for development of new materials with focus on optimization of resources and the reduction of emission in production, use, and recycling. His technical works cover the area of dissolution and yield of the ferroalloy in the steel, thermodynamic modeling of refining process, continuous casting, mechanical forming, and weldability of high-strength microalloyed steels. So let's start, and I invite now Mr. Carboni to conduct the workshop. Please, Marcelo, the audience is yours from now on.
Thank you, Aristidis, for the introduction. Good morning or good afternoon, everybody. Welcome, and once again, thank you for joining this webinar. We will have the two presentations of our invited speakers, specialists on the topic, and after that, we'll have some time for technical debate. The whole event will be conducted in English. However, I will take a minute now to give some general guidelines in Portuguese for someone that may need assistance with English. After that, I will repeat the same guidelines in English. Bom dia a todos. Como eu estava dizendo, o evento será todo em inglês. Essa vai ser a minha única fala em português. A ferramenta Microsoft Teams usada para esse evento permite adicionar uma legenda com transcrição ao vivo. Para isso é necessário acessar configurações, a engrenagem no canto inferior direito do vídeo e habilitar as legendas. Esse recurso não está disponível para acesso via navegador de web, somente pela ferramenta do Teams. Então, se você deseja assistir a legenda, habilite agora essa legenda aí no seu Microsoft Teams. Durante as apresentações, nós convidamos todos vocês a enviarem perguntas aos apresentadores. Essas perguntas serão feitas pelo chat, pela ferramenta de chat aqui, e podem ser feitas tanto em português quanto em inglês, aqui por escrito. Ao final das apresentações, nós teremos 30 minutos de debate, onde essas perguntas vão ser respondidas. Ao final do evento, vocês receberão uma pesquisa de satisfação. É muito importante que todos vocês respondam essa pesquisa para aperfeiçoarmos os produtos e serviços oferecidos pela ABM neste formato de webinar. Okay, I'm back to English now, so I will share the same guidelines in English for our foreign audience. So during the presentations, we invite you to send questions to our speakers using the chat on Microsoft Teams, this tool that we are using. These questions may be written either in English or Portuguese, or even Spanish if you need, and will be addressed to the speakers during the debate after all presentations are finished. At the end of this event, you will receive a satisfaction survey. Please answer this survey once. It's very important for ABM to improve the quality of its products and service to better give you webinars like this. So, with no further ado, let's start the presentations on the current technologies in compact plant for flat steel productions. For the first presentation, and the first lecture we'll have will be the SMS Group latest development in its fin SLAB technology. It will be presented by Mr. Bjoern Kintscher. He is manager for the CSP technology and plant engineering at SMS Group in Duesseldorf, Germany. Mr. Bjoern Kintscher is an R&D engineer of CSP technology at SMS Group. He has master's degrees in mechatronics by Bjoern University of Applied Science. He graduated as engineer in 2009 to 2013 from Bjoern University of Applied Science in mechatronics. Received his master's degrees in 2013 to 2016 from the same Bjoern University of Applied Sciences, and since 2008 he is employed at SMS Group in the positions of technical assistant in the R&D department, fundamentals and models for continuous casting from 2008 to 2013, as an R&D engineer in the fundamentals and models continuous casting from 2013 to 2014, and as R&D engineer CSP technology since 2014. So I invite Mr. Bjoern to start his presentation. Please, Mr. Bjoern, the audience is yours.
Yes, thank you for the introduction. I hope you hear me, and I hope you can see my presentation screen. First of all, thanks again for the introduction. I would like to welcome everybody. Bom dia de Brazil. The topic of my presentation is SMS Group's latest development in its thin SLAB technology. So let's begin. So I want to begin my presentation with the SMS portfolio of compact strip production plants. The upper sketch shows a typical CSP layout with two casting strands, a tunnel furnace, and a compact mill. The production capacity is roughly 0.8 to 1.5 million tons per strand per year. The bottom sketch shows the layout of our new concept, the CSP Nexus. It is capable to produce up to 2.7 million tons per year with one strand and up to 4 million tons per year with two casting strands. But more about the Nexus technology later. I want to start my presentation with the basic CSP plant. With the first CSP plant in 1989, SMS has now more than 30 years of experience in thin slab casting and direct rolling technology. As you can see in the sketch, A typical CSP plant does have 1 or 2 casting machines, a pendulum shear to cut the strand into slabs, a tunnel furnace to heat and to homogenize the slab, and as a buffer for the compact hot rolling mill. The mill has typically 6 to 7 rolling stands, followed by a laminar cooling table to cool down the strip and to adjust the material properties of the product. At the end, the strip is coiled into at the downcoilers. The standard production mode is batch, so coil-to-coil production. So that means that the slabs are cut after the casting machine to coil weight. With the help of a high-speed shear, a CSP plant can produce in semi-endless mode. A very long slab is produced, rolled, and cut into multiple coils right before the coiler. This mode increases the production stability when rolling thin strips. The key advantages of the CSP technology are the vertical caster design, which is easy to access and maintain, the minimized number of process steps, the minimized energy and conversion costs compared to conventional hot rolling mills, the homogeneous temperature distribution, and, as you can see in the bar chart, the possibility to produce almost all typical steel grades. The combination of simplicity and flexibility was a key of success of the CSP technology. Having a look at the reference situation of the CSP plants, SMS built 29 CSP plants all over the world. Our latest CSP plant reference is Big River Steel in the USA, which I want to show you in the following slides. Big River Steel is a newcomer in the steel business. The Greenfield project was realized due to several financially strong investors. The steelworks of Big River Steel is arranged, and the installed technology was chosen with the focus on flexible production and efficient operation. The illustration shows the whole plant after the second phase with the ability to produce 3 million metric tons per year. The second phase is under execution and will be started up next week. The steel melting plant consists of 2 electric arc furnaces, 2 twin ladle furnaces, and an RH degasser. The hot strip production is done by 2 CSP strands with a 6-stand finishing mill. For cold processing, a pickling line, tandem cold mill, a batch annealing furnaces with offline skin pass mill, and a universal annealing and galvanizing line is installed. The entire process equipment, including the environmental equipment and the electric automation, was delivered by SMS Group. As said, Big River Steel will produce 3 million metric tons per year after commissioning of the second phase, with only 600 employees in total. The hot strip thickness range is 1.5 millimeter up to 25.4 millimeter, and Big River is able to produce strips up to 1930 millimeter width. The plant started the production in the mid of December 2016 with a record-breaking startup curve. Here you can see the first months of production. Nearly 80% of the rated capacity was reached in the third full month of production. Big River Steel produces 1 million tons of hot rolled coil after 10 months of production. Up to now, it was the steepest starting curve of all CSP plants. As you can see on the right-hand side of the bar chart, it is quite normal for Big River Steel to produce even over the rated capacity. An example for the production flexibility of Big River Steel is shown on this slide. As a newcomer in the steel business, Big River Steel had no existing customers, and they have to directly produce the orders. Due to this fact, the CSP plant could show its full flexibility. The green vertical lines are showing the start and the end of the production sequence. Considerable thickness changes with a maximum 50 millimeters and a minimum 2.5 millimeters were made in this sequence, together with 3 steel grade changes. The digital future has already begun. Big River Steel is called the Learning Steel Factory. The SMS Digital, a subsidiary of SMS Group, is a team of data scientists and digitalization experts with roots in the SMS Group. The combination with SMS Digital's innovative solutions for data infrastructure, digital products, and machine learning resulted in the first learning and self-optimizing steel mill. (2,700 sensors and 15,000 signals are continuously and permanently stored in the SMS data factory. The huge volumes of data are evaluated and used as a part of a big data system to improve melting, casting, and rolling strategies. The learning steel plant auto-adaptively optimizes its production process as a part of an integrated value chain based on physical plant elements, data-driven models, and system with regards to production planning, product quality, and plant conditioning. The key factor of success is turning data into value. For more information about the Learning Steel Factory of Big River Steel, you can scan the QR code. From the very beginning in this project, SMS and Big River Steel focused on efficiency, minimized energy consumption, as well as minimized emissions. SMS designed and built the whole plant by the selection of components and technologies to achieve these green requirements. That's why Big River Steel received the LEED certificate for leadership in energy and environmental design as the first steel plant worldwide.
Mr. Bjoern, please, just a minute. I think you have this block MC button on your presentation. Can you click it off? We can't click from a part here.
I'm sorry.
Okay, thank you.
Okay, thank you. Having a look at today's global steel market, the green press for environmental awareness is growing. The steel industry has to reduce their emissions and fulfill sustainability requirements in the future. In addition to that, the changing market asks for even more advanced steel grades and challenging dimensions. Combined with the global overcapacities of over 20%, today's market demands are efficiency, flexibility, and promptness to produce steel on a profitable level. The solution which meet these market demands is CSP Nexus. The layout shows the basic Nexus setup with a casting machine, a tunnel furnace, a two-stand roughing mill, a second furnace, a 6-stand finishing mill, laminar cooling, and 2 downcoilers. The Nexus plant is capable to produce up to 2.7 million tons per year with 1 strand, and up to 4 million tons per year with 2 strands. As a 1-strand plant, furnace number 1 has a length of 30 meters, and furnace number 2 has a length of 80 meters. It is possible to produce strips with a thickness of 0.8 millimeters and up to 25.4 millimeters, and a width of up to 2,130 millimeters. The Nexus plant can produce in batch, short endless, and endless rolling mode. Having a look at the product mix portfolio, the CSP plant can produce all typical steel grades, including silicon, multi-phase, advanced high-strength steel for the automotive industry. As you might know, peritectic grades are difficult to produce with a thin slab caster. The combination of high casting speeds and a funnel-shaped mold are not favorable due to phase transformation and the related volume change during solidification of peritectic grades. The Nexus plant is capable to produce such peritectic grades. In addition to that, it can produce ultra-thin, low-carbon grades, as well as heavy-gauge API grades up to 1 inch. Now, I would like to fly with you through the Nexus plant, beginning with a high throughput casting machine. The bow-type caster has a length of up to 25 meters, a casting thickness range from 110 to 130 millimeters, a casting speed of more than 6 meters per minute, and a casting width of 2,130 millimeters, which ends up in a high level of steel mass flow. To ensure a stable production at high steel mass flows, it is mandatory to control the steel mass flow in the mold. The stabilization of the mold level starts with the machine head design. Therefore, the mold, the oscillator, segment 1, segment 2, and the electromagnetic brake is positioned on the foundation independently to prevent vibrations. To control the steel flow, the selection of the interaction and the interaction of the SEN, the established funnel-shaped mold design, and the electromagnetic brake is very important. In the design phase, several CFD simulations were done at SMS. The figure at the bottom shows the result of a simulation with and without the EMBR at a high steel mass flow. The crucial factor is the steel velocity at the mold level. A too high velocity will end up in unstable casting conditions due to uneven melting of the casting powder and an inhomogeneous heat transfer in the mold. At high casting speeds, the strand shell is thin when leaving the mold. To minimize the bulging effect of the strand shell between the rollers, several countermeasurements are necessary. The secondary cooling is controlled by a level 2 process model to guarantee a fast strand shell growth without quality issues. The bearing windows between the rollers are small and staggered to minimize strain. The caster is designed with different roller diameters and roller pitches to prevent bulging amplification. Axle rollers with small diameters are installed in the upper area of the Nexus caster, and intercooled Aztec rollers are used in the unbending and the horizontal area to have the option to reduce the secondary cooling on a minimum if necessary. The next slide shows an option to even extend the product range. For some high crack sensitive steel grades, it is required to cast at low casting speeds. Therefore, the machine head can be changed to use a parallel mold for 150 millimeter casting thickness to realize casting speeds below 2 meters per minute. This option enables the Nexus plant to produce steel grades with a carbon content in the paratectic region. Having a look from the caster platform, you can see the first tunnel furnace, the roughing mill, and the second tunnel furnace. The task of tunnel furnace number 1 is to increase the slab temperature, to equalize the slab temperature for a risk-free production of crack-sensitive grades, to enable the batch process, so the slab is cut before beginning the rolling process in the roughing mill, and to enable the work roll change in the finishing mill. The task of the tunnel furnace number 2 are to enable the independent operation of rolling mill, of roughing mill and finishing mill, to homogenize the temperature of the transfer bar, to raise the temperature of the transfer bar in case of endless production, and to enable the work roll change in the finishing mill without stopping the production sequence. The furnaces are designed for minimum energy consumption and emissions. Ultra-low NOx burners are used in the pulsing mode to always run in the most efficient working range. These burners are hydrogen ready and can be operated with gas, hydrogen mixture, or even 100% of hydrogen. The heat of the waste gas is used to preheat the fresh air by recuperators. Dry rollers with energy savings of up to 85% can be installed in the tunnel furnace number 2 because of the lower atmosphere temperature level compared to furnace number 1. Tunnel furnace number 1 can be equipped with fiber insulated rollers with energy savings of up to 30% compared to concrete rollers. The roughing mill of the Nexus plant is capable to reduce the slab thickness to an optimum incoming thickness to the finishing mill. It allows the caster to always cast at optimum casting thickness in terms of productivity and temperature. Productivity can be even increased, can increase even more by the use of an etcher in front of the roughing mill. The next slide shows the finishing mill with typically 6 mill stands. The advanced guiding system improves the center line positioning and increases rolling stability, especially during thin gauge production. Stable rolling of thin and wide high strength steel grades is supported by a highly dynamic thickness control. The strip temperature is controlled during the rolling process to hit the desired final rolling temperature. An integrated temperature model considers and controls the temperature profile along the entire plant. The well-established CVC Plus system cares for excellent strip profile, contour, and flatness. An outstanding strip surface quality is guaranteed by rolling gap lubrication, gap conditioning, including anti-peeling and roll gap lubrication. The scale growth is considered along the entire plant. The tunnel furnace atmosphere is adjusted to a favorable level of scale formation. State-of-the-art high-pressure descaling systems are positioned in front of both mill trains. Alternatively, the Pyroscale system can be installed, which is a new developed rotary descaling system. It reduces the water consumption by 50%, which reduces the temperature losses. The rotary system designs lead to a more uniform descaling result. Another new development is the convectional roll cooling. As you can see in the left graphic, the work rolls are usually cooled by spray nozzles. The right graphics shows the principle of the cooling by using the effect of forced convection. With this system, up to 90% energy costs can be saved due to less water consumption and less pump power needed. The picture shows an installation of the convectional roll cooling at a German customer. The system is robust, wear resistant, and self-adjusting. So this system became a standard feature in all future SMS mills. The next slide shows the laminar cooling line of the Nexus plant. The latest strip cooling technology is installed and allows a wide range of settable cooling rates. High cooling rates improve the strength and the toughness. Higher strength allows a reduction in alloying costs. Low cooling rates are needed for soft grades with higher formability, for example, deep drawing and extra deep drawing grades. The cooling rates are controlled by a process model to achieve the desired material properties. Even more beneficial is the direct compact cooling. As shown in the picture, the system is positioned directly after the last mill stand. This leads to even higher improvements in strength and toughness, and as a result, in higher savings of alloying costs. Another benefit is a lighter chemistry in the casting and rolling process, because the strength is set at the laminar cooling and not only by the alloying elements. This slide describes the 3 different operation modes of the Nexus plant. In batch mode, the slab is cut directly after the casting machine. This is best practice for thermal progression and energy savings. In short endless mode, the cut is made behind the roughing mill. So caster and roughing mill are working in endless. The benefit is that there's no head-tail flare and therefore no head-tail losses on each slab. This will increase the yield of the plant. In endless operation, the strip is cut right before the downcoiler with a high-speed shear. The entire plant will work in endless operation. This will increase rolling stability of ultra-thin, low-carbon grades. The Nexus plant can produce low-carbon grades in endless without an additional induction heating, which lowers the overall OPEX. As you can see, 3 modes are possible with the CSP Nexus plant. Each mode has some pros and some cons. At the end, the operator can choose the most beneficial mode for each product. The layout at the top shows the basis of the CSP Nexus plant. However, Nexus can be expanded due to its modular design. You can see some examples for performance packages in the table. For example, to enable ultra-thin strip production in endless mode, a high-speed shear can be added. For an even higher production, a second caster and a furnace ferry can be added, maybe in combination with edgers in the roughing mill. For even more grades, the changeable mold is an option, or a combination of furnace and induction heating for a temperature boost when the focus is on silicon grade production. And of course, all these modes can be mixed for maximum flexibility and to fully meet the customer's demands. Once again, these examples should give you an idea for the modular design. Even an upgrade afterwards is possible. The last slide of my presentation shows the first CSP Nexus reference we are currently building for SDI in Sinton, Texas, in the USA. The annual production will be 2.7 million tons per year. There's a provision for a second strand to increase the production up to 4 million tons per year. The maximum strip width is 2,130 millimeters, which will be our widest CSP reference. Can you see my screen? Still, yes. Excuse me. Okay. The strip thickness range is 1.2 millimeters up to 1 inch for API and up to 1 inch for API grades. The whole facility, including melt shop, CSP Nexus, pickling line, cold mill, temper line, galvanizing line, and color coating line, is supplied by SMS. The first coil will be rolled in the second quarter of 2021. If you want to have more information about the SDI Sinton project, just scan the QR code. At the very end, I would like to come back to the record-breaking startup curve of Big River Steel. With SDI Sinton, we want, and we will, beat the startup curve of Big River Steel to set another record in starting up a plant. Thank you. Thank you for your attention. Muito obrigado.
Okay, thank you very much, Mr. Bjoern. I would like to remind all the audience that we are open for questions. So all you need to do is please send questions on the Q&A tag here on the chat on the Teams too. Okay, so To continue for the next presentation, we'll have our second lecture. It's Arvedi ESP, Reaching Maturity in Endless Casting and Rolling Technology, and will be presented by Mr. Andreas Jungbauer. He's General Sales Manager for Primetals Technology in Austria. Andreas Jungbauer completed his master's degrees in electrical engineer and process control at the University of Technology in Graz in 1998. In the same year, he joined Voestalpine Industrieanlagebau in Linz and began in the automation department for continuous casting, where he worked as a project manager for automation until 2004. In 2004, he joined the continuous casting department as product manager for continuous casting. Since 2008, Andreas Jungbauer is General Sales Manager of the Proposals Department for Endless Strip Production at Primetals Technologies. Please, Mr. Andreas, the audience is yours for your presentation.
Bom dia, Brazil. Good morning from Austria. Arvedi ESP plants have now been operating for more than 10 years. In the beginning, it was eyed like something absolutely crazy and impossible. In the meanwhile, Arvedi ESP real endless strip production is the reference for successfully turning around the flat steel production to low emissions, high quality production. In the meanwhile, 10 references of ESP are sold. 5 of them are operating. 3 more will go in operation this winter. The other projects are under execution. Up to now, 59 million tons of high quality steel have been produced on ESP plants and sold at attractive prices. Currently, every month, roughly 1 million tons is produced from ESP plants. ESP lines are currently sold and operating in Italy, China, United States, and to a non-disclosed customer in a different region. The extremely compact layout of the plant can be seen here. The total length of an ESP line is only 180 meters, and it's operating with a high-speed shear at the end, always in endless mode. This means constant mass flow, constant temperatures, speeds. We do not have any speed ups. Subsequently, we have constant cooling, and there are no threading heads, what would risk cobbles or negatively influence workflow life. The direct coupling of caster and high reduction mill here in this area is essential for lowering the roll forces and perfect geometry for finishing rolling. If there was just any meter of a tunnel furnace, all those benefits for real endless operation would have been lost. The split into high reduction and finishing mill is beneficial for thermomechanical rolling, a two-step rolling for thermomechanical rolling for production of HSLA and API production. The strip always runs on constant production conditions until the high-speed shear and is only cut here. Here you see the inverse temperature profile, what means coming out of the caster, the surface is cooler than the center, and this is the big benefit for lower rolling forces and perfect geometry for finishing rolling. The product portfolio comprises everything you can imagine, starting from mild steels over ultra-low carbons, microalloyed steels, multi-phase steels, as well as pipe grades. Arvedi ESP has got an API X70 certificate. Steel for pressure vessels and gas bottles, as well as boron steel and high carbons, round up the portfolio. Further to say is that here we have the tested grades and for further development, that advanced high-strength steels and silicon steels have been tested and are on their way for further development and implementation. Even a DP1200 have been tested. With regards to peritectic steels, this can be made, of course, cannot be made with a funnel mold, but if this would be required, a thicker parallel mold would be implemented to achieve also peritectic steel grades. We have here an overview of the implementations of ESP lines. The Arvedi ESP line can flexibly be implemented according to production route requirements and desired end products. The Arvedi ESP line in Cremona was actually the first one installed in 2009 with an original capacity of 2 million tons. Now in 2020, it was upgraded to a capacity of 2.8 million tons. This was possible as the plant was set up already earlier for such an outlook and giving the possibility for later upgrades. Rizhao Steel followed after this first line Arvedi ESP with the order of 5 lines. Rizhao Steel is running a completely different approach and both companies, both approaches will be explained on the next slides. Interesting to be mentioned are the projects with US Steel, who use Arvedi ESP to better realize their own developed X Generation 3 advanced high-strength steels. The stable endless operation is advantageous for production of this steel. And also the ESP line, especially for thick API grades, shall be mentioned. Also this is important to be mentioned. The two-step rolling is here very beneficial for thermomechanical rolling of HSLA and API steels. You see on the end products that ESP can cover whatever is desired, whether automotive, heavy machinery, construction, pipe steel, appliances, tools. It can be operated with electric arc furnace or with BOF melt shops. We have now a closer look to Rizhao Steel. Both Rizhao Steel and Arvedi Steel have similar ESP line setups, but they are using it flexibly according the best chances for highest profit. Rizhao Steel makes currently highest profit with ultra-thin cold roll substitutes, even when producing high margin of just low carbon steel. Rizhao Steel did not even install a cold rolling line. You can see here after ESP are following the annealing and the galvanizing lines. Saving the investment for cold rolling lines and related operation costs and selling direct application, this is the motto of Rizhao Steel. Even that the plant is capable to produce up to 12 millimeters, the focus is completely on ultra-thin gauges. You see here in this diagram, the possibility is from 0.8 to 12.7 millimeter, but they are mainly producing below 3 millimeter thickness. Nevertheless, Rizhao starts to develop also advanced grades and silicon steels to be ready for future when the current business is changing. Also important to say is that the plant is already exceeding the nominal capacity of 2.55 million tons and is running very well. While Rizhao Steel supplied the liquid steel from a BOF route, Arvedi ESP is using an electric arc furnace route. Arvedi is enjoying in their 3-stand PLTCM the ultra-thin incoming material from ESP as a basis to achieve cold rolled material down to 0.2 millimeter. When you look at the thickness distribution, you can see that Arvedi flexibly uses the full range of the plant, the full thickness range of the plant. Highest profit with advanced HSLA and DB grades for automotive purposes from cheap scrap are in focus. Further on, Arvedi uses the ultra-flat ESP material for its own tube production. In this context, it's also important to mention the possibility of coupling a quantum EAF with an ESP line to a minimal flat for production of premium products from scrap. In this combination, the minimal flat melts the scrap on less than 280 kilowatt hours per ton in a quantum furnace and rolls it to high quality and on less than 132 kilowatt hours per ton in the ESP line. This means beside lowest energy consumption, also lowest emissions and other consumptions at highest yield. Arvedi ESP has been green certified according past 2050 standards by TÜV Germany. Compared to conventional casting and rolling lines, ESP produces 39% less CO2 and 88% less NOx. The biggest benefit is that Arvedi ESP completely omits a gas-fired tunnel furnace, so there are no direct emissions. And due to its compact layout of just 180 meter lengths, no energy is lost during the whole production process. Coming now to the operation. The biggest plus of the Arvedi ESP line is its stable operation. It starts already at the caster, even at highest mass flow of 380 tons per hour, as you can see here. Performed for 8-hour sequences with more than 3,000 tons, the mold level deviation is below 1 millimeter. This gives perfect stability, and this high mass flow is the basis for high rolling temperatures, endless operation, and thus quality strips. After the caster follows directly the high reduction mill. Rolling a hotter and thus softer core requires of course less energy and leads to better shaping of crown and wedge for finishing rolling. The pusher-piler area is the flexibility and safety zone of the ESP line. It allows dummy bar evacuation and feeding and blade production during downstream issues. There is Absolutely no need for a tunnel furnace, which would be just limited in storage capacity. Blade production can flexibly react to any production requirements. Optimized heating is possible with the 10-meter short induction furnace. Short heating at high strip speed means reduced scale loss, and this means increased yield compared to tunnel furnaces. Additionally, such a short furnace requires drastically reduced maintenance efforts. During any operational break, the power can be completely switched off. Finally, important is the fact that the induction heater is built up of 10 modules, which allow optimized control of the temperature with immediate feedback. Due to the perfect shaping of the intermediate strip in high reduction mill, the finishing mill can be run with conventional work roll contours, what allows then wear compensation. This leads to double work roll life campaigns compared to coil or call it batch processes or batch operations. This is an essential operational cost factor. So ESP does not require coffin shape rolling and is fully flexible in width change decisions, as well as in thickness decisions. Someone could now mean that the coil-to-coil mode supported by tunnel furnace would be helpful or essential, but this is not the case, as we can see here on the example of the inline work roll change. The inline work roll change allows to open the work rolls during rolling and to execute the roll change like well known from cold rolling. During the operation, the final thickness is increased as the changing stand is dummied. After roll exchange, the plant goes back to desired minimum thickness and the sequence length is doubled. Here on this page, we have now an overview over the special features for flexible adjustment on different production cases. At the induction heater, higher accuracy for thermomechanical rolling is given. In the end of the finishing stands ultra-early power cooling, a power cooling for high cooling rates for thick API production. And in the laminar cooling, the design of the laminar cooling is essential. On the one hand, low coiling temperatures for DP grades or high coiling temperatures for deep drawing and high carbon grades. Here we are now at the high-speed shear. This configuration allows cutting from 0.6 to 20 millimeter, always in endless mode. The benefits of endless are the constant mass flow, temperatures, speeds. We do not have any speed ups, constant cooling, feedback to changes, and no threading heads. And this leads to the essential benefits for rolling: uniform mechanical properties, extended product range, especially for high strength grades, and higher geometrical quality. All these design features bringing us following operational benefits. The first, the process stability resulting in extremely stable temperatures. The diagram shows a 6-hour sequence where more than 4 hours were produced on a thickness of less than 1 millimeter. And the finishing rolling temperature has a standard deviation of only 2.5 degrees. This means, contrary to coil or batch rolling, we have no temperature fluctuations, and you know always in advance in which position of the plant you have which temperature and which metallurgical conditions. So the process is completely predictable. The shape of the roll strip can be flexibly adjusted as desired. Very beneficial is adjusting a flat crown within the cold strip standard. This allows slitting and increases productivity when producing on full widths. As the strip is completely flat, further cold rolling and processing can be perfectly performed. On the right side here, you see an unrolled 0.8 millimeter coil already with fry. Just with your eyes, you can see there are no quarter buckles or any waves in it. Most appreciated from processors is the fact that ESP material shows uniform mechanical properties from head to tail. There is no difference in yield strength, tensile strength, elongation or grain size. Of course, the plant never sees a head or a tail, and the strip is never influenced by speed ups or other operational requirements as known from coil to coil rolling. At the end, we have then coils with perfect strip quality. Coils do not only fulfill the requirements for hot rolling standards, but also fulfill the standards of cold rolling, narrow standards of cold rolling, and even automotive requirements. All that just with hot rolling and without involvement of any cold rolling plant. During operation, widths, thickness and grades can be flexibly adjusted. Flying gauge changes are a standard procedure at ESP lines. Grade changes are calculated in the caster with the mixer expert, and with the digital twin function of this tool, such changes can be even tested in advance in the office before execution. We see here a sequence which produced 132 coils in 9 hours, more than 2,500 tons. And in total, we had 5 grades produced in this sequence. Low operational costs are always essential for successful plant operation. Here we find a summary of some factors. We mentioned already the low energy consumption due to the compact layout and the lower scale losses. The operating plants show both caster breakouts and breakout rates and cobble rates below 0.1%. And due to the thermomechanical rolling on stable speed, over-alloying can be drastically reduced for HSLA and API grades, as staying above the non-recrystallization temperature is assured. And finally, the much higher work roll life, which we have seen already before. On the sales side, beneficial is omitting the head and tail cuts. Customers appreciate uniform strip quality and are willing to pay much more for endless coils compared to coils produced on coil-to-coil mode. Even more is paid for ultra-thin gauges, which are sold on prices just below the cold roll price. Just today, we learned from one of our customers that this can sell the coils from the ESP line on double profit compared to their also existing hot strip mill, which is operated, of course, in batch mode. So this endless benefits is really appreciated by end customers, and they are willing to pay for it. From part of plant digitalization, I pick out just one example. This is the through process quality control. Data inspection over the entire production line is possible from a single location. Data analysis for product development and customer claims is supported, and complete tracking of the production process is for every coil is also possible. All that results in the products directly made from ESP lines. Examples are boilers, heaters, tubes, galvanized material, structural and high carbon applications, containers, and many automotive applications. What I gave here was an overview of the ESP technology. If you want a deep insight on 10th of December, there will be a live webinar where you can register under meta.ls/ESP 2020. As a conclusion, we can say that ESP can be defined by 3 columns. Lowest investment, because we have a very compact layout, minimum foundation, less piping, cabling, roofing, cladding. Lowest operation costs, as alloying is less, we have very high yield, no heating in idle times, low energy consumption. This is compared lowest cobble and breakout rates, lower scale, and very high work roll life. And almost the highest benefit is the highest high profit that you can achieve with no head and tail cutting, uniform strip quality, outstanding surface quality, certified API production, ultra thin production at full widths, and ultra thin production at full productivity. Thank you very much.
Thank you very much, Mr. Andreas, for this very nice presentation, highlighting the features of ESP. We'll have already some questions from the audience for both presentations. I myself have a couple of questions as well, but before the questions, we should go for the third presentation, the third lecture. That will be Danieli Universal Endless, DUE, or maybe DUE in Italian, the first ever universal solution for flat products is now on stream. It will be presented by Mr. Alessandro Pigani, Vice President of Sales for Danieli, Officine Meccaniche, and Mr. Alessandro, following the master degrees in material engineering learning at the University of Trieste, Alessandro Pigani joined Danieli Group in 2003. During the first 4 years, he worked as hot products process engineer in the technological department of Danieli Win United, the flat products division of Danieli, mainly focused on thin slab casting and rolling technology, both as support to sales team as well as to plant startup team. From 2007, he joined the technical commercial department, still within DWU organization, with growing responsibilities up to present position of Vice President of Sales. He contributed to the development and promotion of the latest Danieli's technologies in the field of thin slab-based plant named Danieli Universal Endless, DUE. So, Mr. Alessandro, please, the audience is yours. You can start the presentation.
Thank you, Marcelo, and welcome to all attendees to this webinar. In the next minutes, I will just take the chance to introduce the latest technology developed by Danieli in the field of thin slab casting and rolling plant, which goes under the name of DUE, Danieli Universal Endless. This concept has been developed taking into account the market requirements and, of course, customer requirements, which has to accomplish with. So looking for a modern plant, possibly on a single strand basis in order to optimize manpower and productivity, which is increased to up to 3 million tons per year of hot roll coils in a single strand caster. By applying production in a flexible way, it means within reach of the same plant, we must be able to cover commodity grades in order to produce ultra thin gauges, but also value-added grades like advanced high-strength steel or thick products like API grades for oil and gas application for pipeline environment. All in all, with the green approach, it means always looking forward for an optimized OPEX, or for minimum transformation costs, as well as for energy saving, which is becoming more and more important nowadays compared to the past. It goes without saying that final products must be of high quality and high tolerances for high demanding application in order to get a proper tool in order to fight on this market, which although the fluctuations which have been made through the present status of worldwide condition, but also there is a lot of competitions in terms of gaining. So this is important, of course, to keep of utmost level the final quality of the products. The Danieli Universal Endless is the result of, let's say, a merging of technologies. So from one side, the coil-to-coil production, which you can see on the left side on the schematic view, where caster and mill are operating independently each other, so each one with the proper mass flow, and the slabs are cut to length by the pendulum shear at the caster exit. So from one slab, we got one coil. And this is a typical QSP configuration, quality strip production configuration, which allows to have a wide product mix, which call for a decoupling of casting and mill. So therefore, having independent control of mass flow, temperature pattern, and main technological parameters. And of course, operational flexibility, since the synchronization between upstream melt shop or within the caster and the mill are managed even by the tunnel furnace, which connects those plant units, providing the necessary buffer time, either to allow the work roll change at the mill without affecting casting operation, but also to absorb possible delays you can get either upstream or downstream. On the other side, whatever is now becoming a quite mature technology is the pure endless production, where caster and mill are connected each other, so are using the same mass flow, and the coils are cut to length by the high-speed shear at the entry side of the downcoiler area. Typical products for endless are thin and ultra thin gauges, which could be made in a stable and repetitive condition, since there are no more threading or tailing outs. Of course, we got the chance even to extend the product range for high strength grades, since during endless we can apply the flying gauge change, so some products can be rolled thinner, wider, and harder compared to the coil-to-coil production. And of course, as mentioned in the previous presentation, also with the endless production, we can get uniform properties through the entire length of the produced strip, since there would be no any more difference between head, body, and tail. Of course, unless as soon as we are applying the flying goat chain, so there would be some transition along the coil. So by merging of those existing technologies, we have been able to incorporate the advantages in a single production line. Of course, getting even some benefit in overcoming some of the limitation that each of the single plant units can get by applying either coil-to-coil or endless. So we have unified in a single production line all the winning features of coil-to-coil and endless, and that's become the Danieli universal endless configuration, made up of a caster of vertical curved design with 130 millimeter slab thickness at mold exit, soft reduced down to 110 millimeter as final slab, followed by pendulum shear, a short tunnel furnace of about 80 meter length in order to connect the mill area, which is made by 8 rolling stand separated between high reduction and finishing stand by installing in the transfer bar area crop shear, induction heating system, and an intensive cooling system. Of course, laminar cooling, high-speed shear, and the coiler area. Important to underline that through the line there are installed 3 high-pressure descaler at caster exit, at the entry side of the high reduction stand, and the last is at the entry side of the finishing stand, in order to always grant an utmost surface quality on the final product. By applying this merging, as we mentioned, of coil-to-coil and endless, we have been able to cover on this just example of possible mix, the lower band of products made in endless, while the thicker band is made in coil-to-coil, in order to select the most economically convenient rolling process mode, because endless is a fantastic tool to play with, but cannot be applied for all the product range of a quite diversified mix. This is both goes in terms of grades, but also in terms of thickness within a single steel grade. With the Danieli Universal Endless, you can see now just a schematic view of the possible reductions on the rolling mill stand, starting from 110 millimeter slab, going down to 0.8 millimeters on the final strip. And in the bottom part, you see the temperature pattern along the line, which of course calls for an intermediate rating, which is made through induction heating system. But in order to highlight the flexibility of the plant, on the same line, also pipeline grades for thicker products can be made, starting from a coarse irregular grain size of the S-cast microstructure. We can get an optimization through the high reduction stands before reducing the temperature thanks to the intensive cooling system at the finishing mill entry side below, in order to bring the temperature below the no recrystallization temperature, and generating into the finishing mill a pancaking effect that, coupled with the proper cooling strategy at the runout table, allow to get accurate temperature control, and so to perform the real thermomechanical rolling also into a thin slab casting and rolling plant, on which Danieli has been pioneering since making API grades since over 10 years now. very important issue is the operation modes. So we mentioned already coil-to-coil, semi-endless, and endless mode. I just took the chance to show some animation just to whom is not very familiar with. So coil-to-coil, we mentioned already. The slabs are cut into line by the pendulum shear at caster exit, and each single slab is rolled into the rolling mill in order to generate afterwards a coil. So from one slab we got one coil. The second rolling mode is the semi-endless. Semi-endless is it consists into making a longer slab on which the length is based on the furnace length itself, and this mother slab is rolled into one piece, could be with or without application of induction heater, through the rolling mill, and the coils are cut into length by the high-speed shear at the down coiler entry side. By applying semi-endless, of course, we can also apply flying gauge change in order to reach thinner products or thinner than what you can get in coil-to-coil mode. And finally, the pure endless mode. So pure endless mode is now becoming more and more familiar to everybody. In this case, there is an uninterrupted slab from caster down to the coiler with an intermediate reheating in the rolling area thanks to induction heating system. And the slab and the coils are cut to length with the high-speed shear. In this case, we can perform thin and ultra thin gauge production. So it means that we got all those three rolling mode which are applicable into the Danieli Universal Endless, and the selection is very easy to be selected by the operator according to the actual steel grade, since not all the grades can be produced for metallurgical reason in endless mode, so at a reasonably high casting speed. So in this case, coil-to-coil is mandatory. And the other aspect is the final strip thickness, because for thicker products, endless is not anymore economically convenient. So therefore, in order to get the optimal OPEX on a case by case, the coil-to-coil is applied, for instance, for the thermomechanical roll product, as we mentioned earlier. On applying the endless rolling, one of the most important equipment becomes the induction heating system, which as of Danieli is fully developed and designed and manufactured in-house. And we are applying the latest technology of transversal flux induction heaters. The new generation allows to get both vertical and horizontal shifting, on which the horizontal shifting is utilized in order to optimize the temperature along the width. So we can select to get cold edge, warm edge, or hot edge according to the case. And the vertical shifting of each single module, is made in order to grant according to the changes on the transfer bar thickness to get always the maximum efficiency of the flux transfer. As of today, automation is now becoming the master. As of Danieli, we are providing an integrated system from caster down to coiler, of course, even the stream as soon as is needed. As mentioned even in previous presentation, now we are into the industry 4.0, so with a lot of sensors and devices installed through the line. So there are a big data available, and all those data are saved into a common repository, which is the Q3 Intelligence, which allows to make either the reporting on the ongoing status of the plant, as well as the analysis, so the offline analysis and the statistical method to find the correlation to optimize the process, also to develop new grades or new process solutions. This is part of this Industry 4.0, are also the visualization of the PPI, of the plant performance indicator, which are some made on some dedicated screen on the pulpits, on the operator pulpits of caster and mill, which are accessible even by remote by the plant managers. So in a single shot, you can get all the main data of the ongoing production. And this is very nice tool in order to get quickly into the picture, even from remote. And this is, of course, coupled with modern layout on the control pulpit, both for caster and for the mill, where you can see, of course, a visibility on the plant and easy access to the operators' systems. The Danieli Universal Handles plant is a running plant. Since now over 1 year, the Nanjing Tan plant in China is under production. Other references are ongoing or in the engineering stage. But now I just took the chance to share some of the achievement got at Shougang, which have a nominal production of 2.1 million tons on the width range from 900 to 1600 millimeter, and the thickness range from 0.8 up to 12.7 millimeters. Startup of the plant has been made in coil to coil. As soon as we got a consolidation of the coil to coil, we move up to the development of semi-endless rolling, and finally the endless rolling has been implemented by getting the first coil after about 45,000 tons from hot roll coil hot test commencement. This has been very helpful even for Shougang, because by making this trial, or by making actually this step-by-step process mode implementation, we have been able to follow even the Shougang order book, because even today Shougang is not producing on stock, but is producing only on based on the actual orders, either within their premises for the downstream facilities or for market. So the production is based on order, and with the Danieli Universal Handles we've been able to follow and together the plant commissioning and the order has been jointly increased in parallel with joint efforts. What we was mentioning earlier was the ability of the Danieli Universal Handles plant to produce in coil to coil, semi-endless and endless mode. Now you can see just a share of what is being made on those three rolling modes. So you can see that thin and ultra thin gauges are mainly produced in full endless mode, while the thicker part of the mix is based and produced in coil to coil mode, with some transient made in semi-endless mode. And to be mentioned that this is easily made by the operator, which can select the best process suited for the ongoing production, ongoing grade and format in a very easy and flexible way. Now, by sharing with you, which I hope that the connection is good enough, just to give you an highlight of Shougang Jintan plant, and I just took the chance to give some additional data, such as the caster is constantly producing at slab thickness of 130 millimeter at mold exit, after soft reduction reduced down to 110 millimeter in nominal condition, although trials have been also successfully made by using 123 millimeter slab thickness. The caster so far reached a very interesting figure of a throughput of up to 6.4 tons a minute, which is a very interesting figure, although we are confident to increase it, to further increase it in order to exploit the potentiality of the machine itself. So far, the sequence length reached the 18 hits per sequence. So it is of about 200 tons, so it means 3,600 tons within the same sequence, or 33 hits within the 24 hours period. So is a very nice tool. In terms of production now, Shougang recently finalized the upgrade of the upstream blast furnaces. So from June, we have availability of liquid steel, and production is presently at the rate of 150 tons per month. By exploiting the flexibility of the Danieli Universal Endless plant, as we mentioned earlier, there is, of course, regular application of the work roll change during production without affecting the casting operation, by thanks to the tunnel furnace that, although is shorter than conventional USP plants, we are enough buffer time in order to perform 10 minutes work roll change at the finishing mill and the rolling mill without stopping the caster. So keeping as long as possible the sequence length. At the same time, also during casting is applied the mold width adjustment regularly, up to 100 millimeters so far, which is recovered by the edger installed at the entry side of the eye reduction stand, and therefore by exploiting at the maximum possible level the yield of the plant. So those are just some of the data, which of course we cannot take much longer within this webinar, but is interesting to get real results from the plant. So a confirmation of what has been the driving force who led Danieli to develop this new technology, who is under the name of Danieli Universal Land, which universal means not that a single system is applicable on all conditions, but that is a system flexible to adapt to the different condition you can get by running a real and modern hot roll coil production plant. So on operational flexibility is a matter of fact. Now, coil-to-coil, semi-endless or endless mode can be easily selected by applying the process that is best suited to each steel grade and product on case-by-case basis, by getting high-quality products and tight geometrical tolerances as requested by customers, as requested by the market itself. And within reach of the same production unit, the product mix can be diversified with a very wide mix covering thermomechanical and multi-phase rolling, ultra thin and thick products like API grades, commodity grades, but also value-added grades, and therefore getting a proper mix between mass production commodity segments and also niche markets, as we have demonstrated during Shougang's entire commissioning. Of course, as we mentioned at the beginning of this presentation, with an eye on the green technology, so to a step ahead into the transformation cost and energy saving, with the proper support of an integrated automation system, which can allow to make either the analysis, the inline analysis, but also the offline one, in order to further improve the process knowledge and the process parameter. So I took the chance to thank the audience for the time, and I hope to being able to properly transfer some of the main concepts which are the basis of the nearly universal endless, which is the utmost technology in order to always get operational flexibility into a running plan. So thanks for all.
Sorry, I was muted. Thank you, Mr. Alessandro, for your very interesting presentation. And I take the chance to thank and congratulate all the speakers that delivered very good and inspiring presentations. So right now we'll start our discussions. So I see you three are already ready to come back on the screen as long as we have questions. We had some questions from the audience, and I would like to remind the audience that even during the discussion and our conversation, you still can send new questions, and I'll do my best to insert these questions as well on our discussion. So, for us to start, I would start with a general question to give an overview of what is the scenario on the plants, on the market for this new equipment, thinking of three basic things. Which is the oldest one for each technology still in operation? It's a brand new technology, but some have been for a longer time. Is the number of this kind of plants increasing in comparison to new plants on the traditional design and layout? And to close this question, do you see this as the future and see that the batch casting and the standard technology of today will become obsolete in some years and will be totally replaced by continuous endless casting and rolling type of installations? So I would like to have your comments on these three topics for our start of discussions. I think for this first question, I will follow the same order. So I would ask Mr. Bjoern to start, and then Mr. Andreas, and finally Mr. Alessandro. So.
Yeah, thank you for the question. As shown in the presentation, the first CSP plant started in 1989, and we have 29 references worldwide over the years, and they are doing a lot of steel grades. And for sure, endless is good for thin strip production, but I don't think that every grade, thickness, and every product can be produced in endless. So that's why I think that that you have to have a batch production, for sure, especially for extra wide products. So as I said, SCI Sinton, the Nexus plant will be capable to produce up to 2,130 millimeters. And I think a combination of all production modes are best for the customer for a full flexible production.
Okay, thank you. Mr. Andreas?
So you asked about the oldest plant, and this was in our case Arvedi ESP, which originally started up in 2009, and it's actually now also the youngest plant which started up, because in this year we already upgraded it and extended the capacity to 2.8 million tons. I see the trend in the world steel market is that the demands for steel are getting higher and higher, and you need to do high quality production, and the demand is that you have increased flatness and equal material from head to tail, and we can cover this from thin to as well to thick to 20 millimeter for even for API grades. And now this is new that we can all the thick grades also we can offer the endless advantages. And to mention the widths, we are doing also plants now with, when we look to United States, which are exceeding the 2,000 millimeters. So I do not see any limitations at this point.
Okay, very good. Thank you. And I'll take the chance to put a question from the most famous Austrian Mineiro guy that I know, that is Mr. Karl Berger, that sent a question specific to Mr. Andreas. To who is he going to sell an ESP plant in Latin America? So I will also put together the question from Paulo from Senai Osasco, asking, is there any plants like this in Brazil already installed? So please, Mr. Andreas.
Yeah, my best greetings to Karl. Good to hear that you're still active. And if you want to enter now steel business, it's the right time. Maybe you want to be the first one in Brazil who installs an ESP line. You know best the advantages of it. No, we are of course always in discussions also around the world, also in South America, and currently we are always available. If someone also now has found the benefits out of it, we are available for meetings and for going ahead on that topic.
Okay, thank you. Now, Mr. Alessandro, please, the questions.
Yes, back to your question. Our view is that there is no just let's say a layout configuration for all season, for all customer, for all market. This is the reason why, as Danieli, we can provide a portfolio of different USP configuration, which on which the Danieli Universal Endless is the latest development, which is applicable to certain customers, which are quite skills, I would say. but there are even today new markets and new customers which are entering into the hot roll coil production, on which let's say the boundary conditions are for perhaps an easy product mix. Therefore, there is no need to get a plant which applied endless rolling. So we can provide even a simplified solution for coil-to-coil rolling, which afterwards can be modularly expanded even towards the endless. This is just an example. So we are proposing let's say a portfolio of possible solutions which are applicable to specific market and specific customers according to the case on the case-by-case basis. Although generally speaking, I agree also with the other speaker. So the market changed in the past. We are in the field of thin slab casting and rolling as Danieli since 30 years now, and the market and the requests changed over the years. Now, even because as simple as that, 15 years ago, nobody were even thinking of endless made on thin slab casting and rolling. And today we are talking about that all three major suppliers are in the condition to provide solutions for endless. So market is changing, and suppliers are, or let's say plant makers like three major players, we are participating to this webinar into the picture, following the market and providing new solutions. So this is part of the game, since thin slab casting and rolling is still to be fully discovered.
Very nice. Thank you. And for our next question, I will take one question that I have previously prepared and also insert some questions from Mr. Dornelas. And the topic that I would like to ask you about is about the operations and maintenance of this kind of equipment. So my concerns are, as a plant engineer is, okay, it's excellent to have an endless equipment that will work continuously, but how much of calendar time can I actually use on it to produce? How much is expected on preventive and predictive maintenance on this kind of equipment? And as well, what is the workforce needed for this kind of operation per shift or something like this, even as operators and as maintenance team? And I will ask you to follow the same order of the answers this time as well. So please, Mr. Bjoern, if you can start.
Yeah, so for operating such a machine or a plant, it depends on the country, but we need around 280 people or persons to run the plant, where 100 of them are for administration and overhead. For the production, for the yearly production, we can say around 310 to 320 days of production. The rest is for maintenance and plant and unplanned disturbances.
Okay, very good. Thank you.
Yeah, for the ESP line, we are also operating and calculating on this roughly 310 days per year. And I can tell you clearly that the ESP line has a planned weekly or every 10 days maintenance of one shift, 8 hours. And the annual shutdown is roughly 1 week. And the plant is in total operated with approximately 160 people. This is really including plant engineers, operators for day and night shift, for the quality department, management of the storage areas, and maintenance, all included. And what is essential, you wanted that you can safely operate it, and this is the exact point on endless operation as we have it on Arvedi ESP. This is a plant that is run completely, fully automatically, and this means when you come to the mill pulpit, you have never seen before such relaxed or even bored operators operating a mill, because operating an endless plant is really boring. You do not wait for the next strip to thread. Maybe you have to confirm new level 2 set points, but there is no interaction. I hope this answers your question.
Yes, this answers, but I hope you don't tell these Brazilian operators, because otherwise they will start playing games, cards, and things like that.
This is, of course, forbidden.
Of course. So please, Mr. Alessandro.
Yeah, I can confirm actually what Andreas just said, because I mean, we have been experienced on making all the 3 rolling methods, and I can say that by implementing the endless, the pure endless, there would be no more requirements compared to a plant who is running in the coil-to-coil mode. Yes, there are the induction heating system. Then a couple of people could be dedicated for maintenance of induction heating system. But generally speaking, the amount of head counts remain unchanged, and could be different from region to region according to the worldwide location and specific needs of each single country. In terms of maintenance, yes, is an average of 6 to 8 hours per week, the ordinary maintenance, and the down, which could be in a couple of 1 week or 10 days per year. This according to the specific need, or according to the, let's say, to the match of other existing plant units and the upstream blast furnace, in case which would be the schedule more tighter, of course, rather than to a AIF-based melt shop. So that depends on case by case.
Okay, very good. Thank you as well. So we'll take another question, but this one is specifically for Mr. Bjoern from SMS. Could you please give more details about the new row cooling system? What kind of nozzles are used, spray bores, slots, and how is the layout? If you can tell something about this, if it's not patent or proprietary information.
Yeah, I would like to answer this question quite general, because for sure it's our technology. But regarding the nozzles, there are no nozzles. The complete cooling system is designed in a way that a water carpet is produced, and this is between the rock roll and the cooling header. So that's all.
Easy and simple.
Yes, for sure.
As to speak, not to implement, of course. So I will combine a couple.
Up to 90% energy consumption reduction. That's a big benefit.
For sure, that's it. That's a big benefit. So I will combine a couple of questions. I have Mr. Heinz, I have Leonard, I have Mr. Carlos Chaves, and I'll put all together, try to put all together in one general question about the quality and the capabilities of this equipment. So what are the greatest challenge as you see in terms of steel grade, which are the most challenging steel grades or industries to fulfill all the requirements with this kind of endless production? Is it API grades? Is it the thickness of the API grades? Is it the deep drawing for automotive industry of exposed parts? So which is the highest, the biggest challenge? Which is the highest thickness you can achieve on I think it will be on the API that will be the greatest challenge, but I'll let you answer. What is the thicker transfer bar that you can achieve on each of the equipments? And last one, this is mine. Is there an R&D on the third generation of advanced high strength steels, such as strip, whip, and complex phase and different approaches on this thin slab casting endless process? And this time I will invert the order, so I will ask Mr. Alessandro to start.
All right, so your question is actually calls for a dedicated webinar, because would take quite a long time to get deeply analyzed. Actually, I would say that in the last decades on the thin slab casting and rolling, many, and this is generally speaking now, regardless the technology applied, there's been a huge development in terms of possible grades, which have been part now of a consolidated product mix. As of today, I would say that compared to conventional Austrian mill, the gap remains so far on the automotive exposed, which so far cannot be yet covered on industrial basis, I would say, on thin slab casting and rolling approach, since trials are ongoing, but there is not yet industrialized solutions to overcome the big reduction you can get on a conventional Austrian mill, starting from 250, 300 millimeters down to 1.5 millimeter or 2 millimeters. So there is a big ratio. What we have done, this concern Danieli technology, has been to progressively increase over the years the slab thickness. Now we are, as I mentioned, 110 millimeters. Trials have been already successfully made 123. Plans are to make tests at 130 millimeters. So to further increase the reduction ratio from slab to strip, which in turn allow to get a wider range of products to be produced. Of course, the application of different rolling modes allow even to exploit the product mix. But as of today, I would say the automotive exposed is still an area where there are margins of improvement and know-how to be developed on this for sure. And on the other hand, for third generation of specialty grades, also on that there are a big market potentially, and trials are ongoing because everybody is looking forward to get the same product with the same characteristics at a lower cost. So that's the fighting between thin slab and conventional approach.
Okay, thank you very much. Very relevant points. Let's see, Mr. Andreas.
Yes, you gave me the question, where are the big challenges? Let's explain it this way. When we announced more than 10 years ago that we will do endless operation and down to 0.8 millimeter, everyone said, the steel world said, this is impossible, no one can do it. We were declared crazy. Then we did it, and now it's accepted, and it's a usual thing. So now we have here in total we have 3 presenters who are presenting endless solutions. Whenever you managed that you found a solution, then it's no more the big deal. And we are at Primetals, we are always pioneering and to go ahead. This can be seen on the fact that we are not only doing the 0.8 millimeters, but 2 years ago already we achieved 0.6 millimeter in endless rolling on a hot strip mill, what no one could even imagine before. And in this way, we are pushing forward all the time. We are developing DP 1200 grade strip 800 X grades and so on. So fortunately, the world does not stand still, and we are moving forward all the time.
That's good. I like this view of moving forward. So, please, Mr. Bjoern.
Yeah. At first, I can confirm for sure exposed parts are difficult to produce because of the zero defect tolerance of the surface. You have to have very clean steel for sure. For exposed parts and even for stainless, let's say. And you have to have maybe an inspection or grinding before the rolling. But for sure, at SDI, even at SDI, the EAF, the electric arc furnace, and the scrap route is designed to deliver very clean steel. Which is required by the production for exposed automotive grades. Let's see where the development is going, and for sure our SMS digital solutions will always support such developments. Regarding the question to the third generation HSS grades, for sure we got a huge R&D department which is always interested and in developing new steel grades all over the world on our big reference situation. And one question was the transfer bar thickness, I think.
Yes.
I can say for API production of 1 inch, we do have a transfer bar thickness range from 65 to 72 millimeters and coming from a slab of 130 millimeters. However, the SDI can even go up to 140 millimeters thickness. And as you saw in my presentation, we are able to even change the machine head to a parallel mold with 150 millimeters for the Nexus plant, which is then capable to produce high crack sensitive grades, just like peritectics, which is always a challenge for a thin strap caster, because we have to cast them on a very slow casting speed range.
Okay, thank you for the questions, for the answer, of course. And I have one other question now. I will change a little bit the subject, and I will tell you that, okay, you convinced me. I'm really interested on having one of these equipment. Of course, I don't know yet which will be the supplier. So what I would like to ask you, and putting some questions from the audience as well, what is the amount of Capex of investment that I have to prepare to have a new plant starting on this, And I would be more polite and ask you to say not in full figures, but as a comparison to a traditional mill with a slab caster and then a full rolling. What is how much lower is the capex that I will have to start a new mill on this? So I have to say that when we talk about figures and negotiation, the one that speaks first is always not the most favorable, but so this time I will change to Mr. Andreas for the first one. So sorry about this, because I know that when we start negotiating is like this, but please.
Yeah, the challenging on this question is, like, if you ask me, I want to buy a house, how much does it cost? I want to buy a car, how much does it cost? You can get the car from 10,000 euro and you can pay 100,000 euro for a car. Both are cars. Even when not saying direct figures of values, it's also difficult to answer that. The equipment, this is really is impacting, but also you have to say the surroundings, how much space will you need? Because it's not enough to talk about the costs. When you have an ESP line, for example, you need roughly 15,000 square meter. Compare it with an integrated plant, you are on a range of almost 100,000 square meter. This gives you already a ratio on the relation, and this is the most detail that I can say on the this generous question. And there is then only answer when you have really a picture, what is the desired plan, what shall be done.
Okay, thank you very much for doing your best to answer such an open and confused question. So I will make this challenge as well to Mr. Bjoern.
Yeah, thank you for the question. For sure, I can confirm, Andreas. It's up. I mean, it's due to the configuration how much the plant or the whole facility will cost. I spoke about the modular design of the Nexus, and as you can remember, every modular has changes the price. But for sure, SMS is not always the cheapest supplier, but there's a reason behind why SDI invested now $2 billion US, and Big River Steel invested $1.6 billion. So that's it.
Okay, thank you very much. Very, very well answered. Please, Ms. Alessandro, don't run away. You still have to answer as well.
Yeah, sure. Well, I like actually the example that Andreas made on the car or on the house. This is appropriate actually, since it's a difficult question, so it's difficult to answer as well. What we can say, and I believe that all we can agree on that, is the regardless the configuration, surely the capex of a thin slab casting rolling complex is lower than a conventional Austrian mill based solution. So whatever now could be the conventional caster, heating furnace, and rolling mill configuration. How much lower depends on case by case. This is difficult to answer. Another parameter actually to be considered is the productivity. So normally conventional Austrian mill could be I don't know. I could say higher than 3 million, but normally I would consider a figure of 5 million tons per year production compared to a thin slab casting now, which could be between 2 and 3 million tons. So also this has to be considered. Of course, to be mentioned that the gap between thin slab and conventional has been reduced over the years. So, I mean, if you're considering 30 years ago with the first application of a CSP or whatever now is the supplier, I mean, I'm just making some general consideration. It was about to get 1 million, 1.2 million tons per year per strand. So much lower than what you can get today with the modern technology applied. Consider that today we have cases, or I mean, at least as for Danieli, we have cases of thin slab casting rolling plant which can go up to 4 million tons per year. So I would say comparable with a conventional Austrian mill approach. And that becomes interesting, that as soon as you can get the same production level, but you can get much lower Capex involvement, that becomes interesting in terms of return of investment. So it's difficult to give precise figures by just a general discussion. But what I can say is that the trend is to get higher production from a thin slabs, and therefore even a bigger gap compared to conventional process route.
Very nice. Thank you very much. This both of you, all you three answered in a very interesting way, and I think helped people to make their mind and to understand a little bit better how valuable can this solution be for them. So since we are almost running out of time here, because the discussion's been very good, I would like to make one final question, and with this question I would like you to make your final considerations about this discussion. So the question is very simple. What is next on this technology? How to address the challenge, the digital transformation that steel industry is going through, the aim for lowest inclusion level and cleaner steel, and the really demanding surface quality that steel products are facing nowadays. What is next on this technology to address these things? And your final consideration. So I'll ask Mr. Bjoern to start this time.
Okay, so next is Nexus. So I think for sure the emissions and the sustainability will get more important. So I talked about hydrogen in the tunnel furnace. But also overall energy consumption has to be low. To have a low OPEX and to have to lower the emissions. I talked about the SMS Digital and the Learning Steel Factory, which is already installed at Big River Steel, and for sure SDI Sinton, our first Nexus reference, will be a learning steel factory too, and they will help us to even increase product quality, surface quality, and lowering the emissions, and even get more profitable in the production of steel.
Okay, thank you very much. Mr. Andreas, por favor, please.
The steel producers are always demanding more from their plants because they have to compete on the market. They have to compete on lowest costs, and they have to deliver best quality. So with operating in a combined endless casting and rolling process, and especially in real endless casting and rolling, the factors of uniform strip quality, outstanding surface quality, and so on is given already. And as we know already also how they are operating it, our customers, we are impressed how much profit they can gain from that plants. And coming back also to your question about the price, it's the investment of such a plant. When you have this investment back in really much less than 2 years, as we see, then it's not really the question how much this investment really is, because when you continue on producing just commodity products, then you will come to the point that you are lost. You have to diversify on the market. You have to find new things, and together with ESP and also with our possibilities now to do developments with the digital twin of the ESP, because digitalization is already completely implemented, and with our digital twin solutions you can develop new steel grades in much shorter time without big investment costs. This gives you an advantage, and what is more and more always the pressure, this pressure will naturally increase, is the low emissions, that you have a green plant, because steel industry is always getting more and more in criticism with regards to emissions, and so this is an absolute must that you fulfill. Requirements are even better, and at the end, what only counts are revenues and profit. And we are always developing and looking forward in that direction, and we are convinced that with Arvedi ESP we can fulfill such targets.
Okay, thank you very much, Mr. Alessandro.
Yeah, you ask what next. I would say that as Danieli, we are already thinking on next. It means the Danieli Universal Endless, we have commission at Shougang is already an answer to your question. So what next? I believe is the major technological innovation of recent years, because we have introduced the important concept to get the utmost flexibility on operation and on production by applying coil-to-coil, semi-endless, endless in the same rolling line. So I believe that what next is what we are doing now. Yes, of course, improvements are still possible. Fine-tuning is, of course, is a must on all facilities. But I believe that already a big jump has been made in this year in order to really move to a next generation of modern plant. And this could be coupled with the previous question of how to further exploit the product mix in order again to close the gap with the conventional route and still get advantage in order to let the thin slip casting and rolling become a winning concept of the next short and medium term future.
Very good. Thank you very much, Mr. Alessandro. And with this, I think we finish the session of discussions. So I would like to once again thank you each one of you, Mr. Bjoern, Mr. Andreas, Mr. Alessandro, for the very good presentations and the very fruitful discussions that we have. And right now I will handle to Mr. Aristidis to make the final remarks. Thank you very much.
My sincere thanks for all of you for the excellent presentation and the discussions. Some comments just to close. We really believe during the presentation you talked about the local situation. We really believe the potential of Brazil in increase the internal steel consumption. We need all kind of investment in infrastructure and so. So sooner or later, we expect to have investments to upgrade our plants or new investment in the steel production. And for sure, the innovative solutions that you presented here must be considered as mandatory for successful new projects. We thank you again very much for your contribution. We inform that we are also satisfied with the audience. We reached more than 100 participants in line with our expectation. And we'll have other similar webinars. A message for the audience. The next one will be in December 2nd. It will be about blast furnaces. A slightly different approach because the idea is to present the technologies to control the blast furnaces flexible operation, mainly in this to meet the actual market demands that's in the very unstable scenario. How to reduce production, how to restart safety the blast furnaces. Also, it will be performed by the main technology companies with the specialists. Thank you for everybody and hope to see you in next December. Goodbye for all.